Hello everyone, welcome back to Penglam Quack tutorial. Here we are the lecture series 6 of plant anatomy. In this lecture, I'll talk about tissues in plant, organization, apical meristem, theory of pseudapical meristem. Stay tuned and continue to watch this video. First, let's talk about plant cells. Basically, these plant cells, they are the basic building blocks. They can specialize, inform, and perform a specific function. These plant cells, by working together or groups of cells, they will form a tissue and they can support each other and survive. These are the levels of organization. Atom, as you already know, that it is the smallest unit of matter that has the properties of an element. Groups of atoms will form a molecules, groups of molecules form a cells, groups of cells will form a tissue, groups of tissue will form an organs, and groups of organ will form the whole plant. Groups of whole plant body will form a population. These are the levels of organization which we can discuss. Tissues. Tissues, it is a group of cells that are alike. That means same in origin, same in structure, and they'll perform the same function. These are cells, group of cells, one tissue. These are groups of cells. We can call it as tissue. They are alike. That means same in origin. And if you look at the structure, more or less it is similar, and they'll perform the same function. These are groups of cells called tissue. And if you study this tissue, it is called histology. On the basis of stages of development and origin, plant is made up of different types of tissue. There are two principal groups that are number one meristematic tissue and number two that is permanent tissue, which will be discussed in the next slide. And these are tissue, the protective tissue, that is the epidermal tissue, and this is the meristematic tissue. These are parenchyma tissue, sclerenchyma tissue, collenchyma tissue, xylem tissue, and phloem tissue. Outline classifications of tissue. Tissue we can broadly divide into two types, that is meristematic tissue and permanent tissue. Meristematic tissue can be further subdivided into based on origin, that is primary and secondary, and based on function, protoderm, procambium, and ground meristem. Based on position, apical meristem, intercalary meristem, and lateral. And based on plane of division, mass meristem, plain meristem, and rib meristem. Permanent tissue can be further divided into simple, complex, and special. Based on your syllabus, we will study only simple and complex. This special, it is outside your syllabus. Simple tissue can be further divided into A. Parenchyma, B. Collenchyma, C. Sclerenchyma, and this sclerenchyma can be further subdivided again into fiber and sclerate. Complex permanent tissue, they are xylem and phloem. These are the elements. A. Trachary elements. Trachary element can be further divided into tracheids and trachea. B. Xylem parenchyma. C. Xylem fiber. D. Phloem fiber. Phloem can be divided into sieve elements. Sieve element can be further subdivided into sieve cells and sieve tube. And B. Component cells, and C. Phloem parenchyma. Special permanent tissue, number one, that is internal secretory structure and external secretory structure. A. Glands and ducts. B. Latissifiers. This latissifier can be further subdivided again into latex cells, and number two, latex vessels. External secretory structure. A. Glandular halls. B. Nectars, and C. Hydatodes. In the next slide, we'll discuss about meristematic tissue in details and some important theory proposed by botanists about the origins of apical meristem. And based on your syllabus, this permanent tissue will study or discuss only simple and complex permanent tissue, but we'll skip this special permanent tissue because this is out of your syllabus. Here, let's talk about meristematic tissue. The term meristematic tissue, it was coined by C. Nageli in the year 18 58. And this meristematic tissue, they are the centers of mitotic cells division and are composed of groups of undifferentiated self-renewing stem cells from which most plant structure arise. The adult plants of vascular plants, that means both xylem and phloem, those plants which have xylem and phloem, they are called vascular plant, is the results of a meristematic activity. And this meristematic, they are also responsible for keeping the plants growing. Meristematic tissues, they will be present at the pseudapical meristem, lateral meristem, and root apical meristem. This pseudapical meristem will be present at the tip of the shoot. That is, the terminal buds contain a shoot apical meristem. Because the plants, they need to grow upward. In order to grow upward, meristematic tissue will be producing the new stem or new tissue will be produced because of the meristematic tissue. These are the leaf primordia. Leaf primordia means a lateral outgrowths from the apical meristem that develop into roots. And here the root apical meristem will be present just above the root cap. This root apical meristem will produce new tissue and they'll be producing new cells, and at the same time they can also produce root cap. The last one, there is lateral meristem. They are present mostly in a woody plants, because the woody plants, they need to increase the guards, that means the thickness of the stem. Lateral meristems are of two types, that is co-cambium and vascular cambium. In woody plants, the vascular cambium, co-cambium thicken the stem, they mean to increase the guards of the stem and the roots. Some important characteristics of meristematic cells or tissue. These meristematic cells, they are isodimeric, that means they may be oval, spherical, or polygonal in shape. And they have generally dense, the cytoplasm will be dense. They will be having thick cytoplasm with prominence. Nucleus will be visible easily, or clear nucleus will be present, and the vacuoles will be absent. In case if it is also present, it will be very small. Vacuole will be very small, but in majority of the plant cells, vacuoles are very big. And the cell wall will be thin. It will be thin, elastic, and the cell wall will be made up of cellulose, because they are most actively dividing cell, because they keep on dividing and dividing. And meristematic cells, they are self-perpetuating. That means they keep on making new cells indefinitely. This picture, it represents the part of stem with apical meristem. They are all meristematic tissues. Diagram in longitudinal section, which are cut in a longitudinal section, not in transverse section, and in 4 cross section, 1, 2, 3, 4, with their basipetal derivative. Here, since it is young, it will have a protoderm and ground meristem and procambium. Next one, it will be much more mature than the apical meristem. Here it will start forming the epidermis, outer layer, cortex, mostly they are rich in parenchyma cells, and pericycle, primary phloem, which is produced from cambium, and vascular cambium would also produce xylem, primary xylem. Here this one will be a bit more mature. They'll produce another cells, epidermis, cortex, pericycle, primary phloem, cambium ring, primary xylem, and pitch. This one, it become more mature. The guard, that means the thickness, will keep on increasing because of the activities of all these cells, mostly secondary growth. Outer layer epidermis, cortex, pericycle, primary phloem, secondary phloem, cambium, and secondary xylem, primary xylem, and pitch. It was adapted after Meyer in the year 1965. Classifications of meristematic tissue. Based on position, we can classify meristematic tissue into 3 types. That is apical meristem, intercalary meristem, and lateral meristem. Based on origin, primary meristem and secondary meristem. Primary meristem, that means it is derived from embryonic stage and differentiated into primary permanent tissue. Secondary meristem Mostly it is derived during the later stage of development of the plant body, and it produces what? That is the cocambium and interfascicular cambium. Based on function, we can classify meristem into three types. Again, that is protoderm, procambium, and ground meristem. This protoderm mostly will give rise to the outer surface, that is epidermis, stomata, and hairs. Procambium will give rise to, or they will be present at the center, that it will give rise to primary vascular tissue. Example, xylem. They will transport water and minerals from the soil to different part of the stem, and phloem will transport food which is prepared from the leaf. Ground meristem, it gives rise to all tissue except epidermis and vascular strand. This ground meristem, it will include cortex, pericycle, and pit. Based on plane of division, three types, that is mass meristem, rim meristem, file meristem, and plane meristem. Mass meristem, that means it divides in all plane. It can divide in all plane. Suppose if it's a tissue, it will divide in any plane. That type of meristem it is called mass meristem. And rim meristem or file meristem, that means it divide anticlinarly. Anticlinarly means this type of division. This type of division in one plane. They will divide in one plane. Example, developments of cortex and pit perpendicular to the surface. Plane meristem divide anticlinarly into plane. Example, developments of, they will produce epidermis. This is a periclinar, that means parallel to the surface, and this is perpendicular to the cells. This is the difference between anticlinar and periclinar division. This picture is a schematic diagram showing the position of meristem in shoot in longitudinal view, and the parallel lines indicate the youngest area of meristem. Keep in mind that shoot meristem is of two types, that is apical meristem, intercalary meristematic region, and lateral meristem. This apical meristem, it is present in apex of roots and shoot, and it is responsible for increase in the length of the plant, and it is called primary growth. To increase the height or the length of the plants, apical meristem is needed by the plants, and they are present at the tips of the plants. The second one, intercalary meristem region, it occurs between the mature tissue, and it is responsible for the elongations of internodes. These internodes mean, suppose if there is one node and here we have another node, and this distance between two nodes is called internodes. So in order to increase the elongations, or in order to increase the internodes, we need intercalary meristem, or the plants need intercalary meristem. And lateral meristem, they will be present along the longitudinal axis of the stem and roots, and it is responsible for secondary growth, because to increase the girth, this is the where lateral meristem, lateral means the side, to increase the thickness or the girth, 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 and this it produce vascular cambiums, and cocambiums are the products of lateral meristem. So to increase the thickness or the girth, the plants need lateral meristem. There are three important theories of pseudapical meristem. Number one, that is apical cell theory. Number two, Histogen theory, and Tunica-Corpus theory. Theory of pseudapical meristem. The first one, that is apical cell theory. And this apical cell theory is proposed by Hofmeister in the year 1852, and it was further supported by Nageli in the year 1859. According to this Hofmeister, apical cell theory means a single cell will be present, and it is a structural and functional unit. From this one, they will give rise to different parts of the stem, or different parts of the leaf, or different parts of the tissue. This apical cell governs or controls the growth and developments of the whole plant body. One drawback is that it is only applicable in case of algae, bryophyte, and in some pteridophytes. But this apical cell theory is not applicable to seed plant. That means angiosperm and gymnospermic plants, and this theory is concerned with shoot and root apical meristem. Then it's applicable both in case of shoot apical meristem and root apical meristem. Keep in mind that it is applicable in lower plant like algae, bryophytes and pteridophytes, but not in higher plant like the seed plants. They are angiosperm and gymnosperm. The older apical cell theory was replaced by Histogen because it is not applicable for seed plant, that is angiospermic and gymnospermic plant. This Histogen theory is proposed by Hansen in the year 1870 and further supported by Strasburger in the year 1868. And the theory stated that the main plant body arises from a mass, a group of cells, that is a meristematic cells. It consists of three zones, or this three zone is called histogen. Number one, that is dermatogen, peribelum and plerome. These are the three zone, or it is called histogen. And this theory is concerned with the shoot and root apex because it is applicable in case of shoot apical meristem and root apical meristem. Keep in mind. And one more important point is that this Histogen theory is not applicable in case of angiosperm, but it is applicable in case of gymnosperm and some lower plants. The three zones are number one, that is the dermatogen, peribelum and plerome. Or the outermost layer, that is the dermatogen. It is the outermost single cell layer, and the cells of this which divide by radial walls, and mostly it will give rise to epidermis, mostly the single cell layer. But some exceptional case, in some cases the cells of this layer, since they divide by tangential, that is the pericliner, parallel to the surface, as well as radial wall, then they can give rise to multiple layer, more than one layer, in case of ficus leaf. The second layer, that is the peribelum next to the dermatogen, and it is a middle layer because peribelum is the intermediate zone lying in between the dermatogen and the plerome, and this zone is composed of isodimeric. The shape of the cells will be same side, they will be having same diameter, and from this peribelum primary cortex is formed. Cortex, they are present below the epidermis but outside the vascular bundles, and the innermost layer of the cortex, this innermost layer of the cortex, and they will form or differentiate into endodermis. Endodermis will be present just outside the vascular bundles. Here there is the plerome next to peribelum. This plerome is the innermost layer, and plerome is the center core of the apex, consisting of cells extended in longitudinal direction. And these cells, it can divide in all plane, either anticlinally or periclinally. Because of that one, it make the central cylinder, that is the stele. This stele, it consists of pericycle, primary vascular tissue, that is xylem, phloem and cambium, and it also produces medullary ray and pits. This plerome remain covered by dermatogen and peribelum. Basically, this Einstein-Histogen theory is both applicable in root and shoot apex, but we have to keep in mind that it is not applicable in angiospermic plant because of the following two reasons. Here in angiosperm, sharp distinction between peribelum and plerome in the apical meristem is absent. In angiosperm, the origins of different regions of the plant body from the sharply defined histogen cannot be demonstrated. Because of these two reasons, keep in your mind that it is not applicable in angiospermic plant. The third important theory from pseudapical meristem, that is the Tunica-Corpus Theory. This Tunica-Corpus Theory is proposed by A. Smith in the year 1924 and further supported by Foster in the year 1949. And this theory is based on observation of angiosperm, mostly for angiosperm shoot apex. And according to this theory, there are two zones occur in the apical meristem, that is the outer layer, that is the tunica, and the corpus, inner layer. In fact, In lower vascular plants like the pteridophytes and even in some gymnosperm, a sharp distinction between tunica and corpus is lacking. Keep in mind that because tunica and corpus is lacking in pteridophytes or bryophytes or gymnosperm, it will not be applicable in case of gymnosperm and lower plants like the pteridophytes. But in angiosperm, the demarcation between the two zones is prominent. That is clearly visible. Because of that one, this Tunica-Corpus theory is only for angiospermic plants. Keep in your mind. Tunica. Tunica, it is the outer covering zone composed. It is outer covering zone composed of one or more peripheral cells. This layer can be one or more. Here in this diagram, it is one layer. And they will enclose, I mean they will cover the central mass of the tissue, that is the corpus, and the cells of tunica divide mainly anticlinally, that is the in this division perpendicular, bring about surface growth. This epidermis or outer layer is the surface growth, and the tunica cells are smaller than the corpus. If you see here, it is much smaller than the corpus cells, these tunica cells, and each tunica layer developed from a small groups of separate initials. Initial means start or the starter. They can develop independently. They have their separate initial. The place where it develop, it will be different compared to these cells. Here also they will have separate initial. They are in the place where it start developing. And the numbers of tiers of initial is equal to numbers of layers of tunica. If there is different layer, the numbers of tiers of initial is equal to numbers of layers of tunica. That is the meaning. And from the outermost layer of the tunica, epidermis develop. Epidermis is developed in this tunica layer, but other tissues like the cortex, pit, vascular tissue also can be developed from the tunica or from the corpus or from both, according to ISAP. The second layer, that is a corpus. Corpus is the central core. This corpus is central core and mass of cells surrounded externally by the tunica. And these two regions differ in structure, and the shape will be different because due to different rates of cell divisions and methods of growth are totally different from tunica and the corpus. And the corpus cells are much larger than the tunica cells, and it divides in various planes. That means it can divide anticlinally and periclinally, so that a mass of irregular arranged cells is from being about increase in volume. Since it can divide in anticlinally and periclinally, the mass of cells are irregular in cells and they can increase the cells size. And the corpus originates from its own initials. They have their own initial start located beneath those of the tunica. Beneath means below the tunica. They have their own origin. And the corpus zone give rise to pit, the vascular bundles and parts of the cortex. Keep in your mind this, it's very important. These vascular bundles, it will include xylem, cambium and phloem, and it will give rise to cortex, pit, the vascular cambium and parts of the cortex. Other than the three types of theory which we already explained, these are other theory to explain the structural organization of shoot apex or shoot apical meristem. Number one, that is the histogenic layer concept. It was proposed by H. Darman in the year 1947. So instead of naming the different layer of the apical meristem, he named the different layer as L1, L2, L3 and L4 and so on. So here L1, L2, L3 and so on, or L4, L5. And this layer you will be able to easily observe under a microscope, and also by the assumption based on the orientation of cell division. According to this histogen layer concept, this L1 and L2 we can call the tunica, and next to that L2 from L3 and so on we can call the corpus, that is the innermost layer. And from L1 and L2 they'll produce epidermis, subepidermis and some portion of the cortex. From L3, L4 or L5 they'll produce the pit vascular bundle or the corpus. The second theory, that is Mantle Core Concept, and this concept was proposed by Bob and Chan in the year 1950. The term mantle is used for the dome-shaped outer layers of the apex. This is the dome-shaped outer layer of the apex. This is called mantle, and the core or the inner shell must covered by the mantle. The core will be further covered by the mantle. This is a core called the core, C-O-R-E, core, and it is further covered by the mantles. In this concept, mantle is used for tunica. This mantle portion is used for tunica, and core for the corpus. That means similar with tunica and corpus, that's only the name. That is Newman in the year 1961 classified vegetative pseudapex into three types. Number 1, monoplex. Number 2, simplex. 3, that is duplex. This picture represents monoplex, this is simplex, and these two, it represents duplex. Monoplex, in case of monoplex, there is only one initial dividing periclinally. One initial means if there is one initial, that is existential means existing or occurring at the beginning, and this divide periclinally. This is how they divide, it is parallel to the surface. They will divide only one initial dividing periclinally, and this time is found in many vascular cryptogams. Cryptogams mean they are pteridophytes. Vascular cryptogams because they contain xylem and phloem. Those cryptogams which contain xylem and phloem, they were called vascular cryptogams. Number 2, simplex. In this, the apex is composed of several initial, more than one initial, but in a single layer, and the initial divide periclinally as well as anticlinally. This is the picture. It contains more than one initial. One starter will be present, and the layer will be single initial, and this divide periclinally, that is parallel to the surface, and anticlinally perpendicular to the surface. This is how they divide periclinally, anticlinally, and this type is found in gymnosperms or gymnospermic plant. In this gymnospermic plant, the seeds will be naked. Third one, duplex. In this type, several initial, more than one initials origin will be present in many layer. They will be having many layer. This is one layer, second layer, and third layer. At the apex, it will be present at the tip. The initials of the surface layer divide anticlinally. This one, they will divide anticlinally, that is in the perpendicular formation, while the inner layer divide in many plane. They can divide the inner one, this inner next to this one, they can divide anticlinally as well as periclinally. This type is found in case of angiosperm, that is seed will be closed and they are flowering plants. Keep in mind, duplex is for angiosperm, and simplex is for gymnosperm, and monoplex is for vascular cryptogam, that is pteridophytes. That's it for pseudapical meristem or theories of pseudapical meristem. I hope that's helpful.